Okay, so now let's look at some example problems for how we could use this to find our function, how we could use indefinite integrals to find functions given certain pieces of information. So we're told that our derivative of our main function is going to be 2 over the square root of x. And we're given that we have the point 1 comma 7 as part of our graph. And this, in order to find what our actual function is, then we have to have this extra piece of information. Without it, we can only give general answers when we're doing indefinite integrals. The first step that we're going to need to do is we're going to need to integrate. So we look at this function as dy dx equals 2 over the square root of x. You're going to want to rewrite this in terms of a rational exponent. So we have a coefficient of 2. Our base is x. It's in the denominator, so it's negative, and it's a square root, so it's a half. So we have 2x to the negative 1/2 is going to be what our derivative is. So when we integrate when we integrate 2x to the negative 1/2, what we need to do is, first off, you rewrite your function. You add 1 to your exponent, and you divide by that new exponent. Negative 1/2 plus 1 makes 1/2. We then have to divide by the 1/2, and we add c. Okay? So if we simplified this, you would end up with 4x to the 1/2 plus c. And that equals f of x. Okay? Or, in this case, since we're using dy dx, it equals y. So up here it says, when y is 7, x is 1. So what we're going to do is we are going to write our, use these points with our new equation to figure out what c is going to be. So if y is 7, x is 1, so we get 4 times 1 to the 1/2 plus c. So you get 7 equals 4 times 1 to the 1/2. 1 to the 1/2 is 1, so we get 4 plus c. So you should end up getting c to be 3. So what we can find is when we take all of this information and put it together, we know that our graph, our equation, is going to be y equals 4x to the 1/2 plus 3. That is the only function that has both these properties, that its derivative is 2 over the square root of x, and it also contains the point 1 comma 7. Now, what if I had a second derivative explained to me? Now, that means I need 2 pieces of information in order to find my regular function. Not only do I need to know what the slope of my function is at a particular point, I need another point on the graph as well. Well, they've combined 2 pieces of information together to help us. They've said the slope of f, so that's what we're looking for, or you could say even the slope of y, or dy dx at a certain place. So they say dy, or so the slope of y, and this is, sorry, I should say at negative 2 comma 17 is negative 5. So our derivative, the derivative of y, so dy dx at 2 is negative 5. And we also know that for our regular function at negative 2 is 17. So I'll show how to put all this information together to find our answer. So we start off, we need to take the integral of our second derivative. The integral of 3x plus 4, that's going to be 3x squared over 2 plus 4x plus c. So some constant c, we don't know what that is. Well, it tells us that the slope of our graph, so this is dy dx, so dy dx equals 3x squared over 2 plus 4x plus c. The slope of our graph at -2 is -5. So we can sorry guys. So what we can do is we can replace some of this information. So dy dx is -5. And x is going to be -2. So we've got to plug this information in for ourselves. So we get 3 times -2 squared over 2 plus 4 times -2 plus c. So we need to go forward and solve. -5 is going to equal, well, -2 squared is 4, so we get 12 over 2, which is 6, plus a -8. So this is the same thing as subtracting 8, plus c. So you end up with -5 equals -2 plus c. So c is going to equal -3. So we have found here that our derivative dy dx is going to equal 3x squared over 2 plus 4x plus a -3, so we're going to just say -3. So this is our derivative function. We're certain about that because we know at -2 we have a slope of -5. And because of that, we were able to plug this information in here to find what our c is. Now I'm going to move down to the next slide. So dy dx and is 3x squared over 2 plus 4x minus 3. Okay, so what we need to do now is combine that with our last piece of information. So it says that we have the point -2, 17. This is talking about our top function. This point exists, and that's our top function. So what we need to do is integrate this. So when we integrate this, so we integrate 3x squared over 2 plus 4x minus 3. What do we get here? Well, if we integrate 3 halves x squared, you're going to, everything's the same. You have to raise your exponent of x by 1 and divide by that. You then take 4x, now squared, we divide that by 2. The -3 becomes -3x, and then we have to add c on to the end. Or you could use d if you want to show that that's a different version, but you just need some letter that signifies that you have something extra. So we know here that y is going to equal, let's simplify these. So if we're dividing by 3 is the same as multiplying by 1/3. And so this is actually going to become x cubed over 3. Or excuse me, x cubed over 2. So we get x cubed over 2. 4x squared over 2 becomes 2x squared. We have -3x, and we have plus c. So now what we need to do is use this information, plug it in, to find out what our top function is going to be. So we take 17, plug it in for y. We take -2 and plug it in for x, so we get -2 cubed over 2 plus 2 times -2 squared minus 3 times -2 plus c. So now we just need to solve for c and find our final answer. So we got 17 equals -2 cubed is -8 over 2. 2 times -2 squared, that is 8. Minus 3, or -3 times -2 gives us a positive 6. And we have a plus c. So we have 17 is going to equal -4 plus 8 plus 6 plus c. So let's combine some of this stuff. So negative 4 plus 8 plus 6, that should give us a positive 10. And then you can see that C is going to equal 7. So when we put all of this together to find our final answer, okay, sorry about that delay. So we end up finally with our main equation being y equals x cubed over 2 plus 2x squared minus 3x plus 7. So the main thing that you want to know is that every piece of information can help us out. You just have to determine if they're talking about slope, the slope at a certain point is this, you need to be using your derivative equation, or dy dx. That's what you're going to use. If they're giving you a point, so like the point in the top right corner, negative 2, 17, you use that along with your regular equation, so your y equals equation, in order to figure out whatever that extra constant is when you do your indefinite integral.